Alright, so let's look at this axis of symmetry in a bit more detail. So, given a parabola, let's consider a segment that connects the two zeros, the two x-intercepts of our graph. Take a look at this. Okay? So, what's the relationship between this segment and the axis of symmetry? So, if I put in the axis of symmetry, this is basically the same thing you did in your little folding activity here. That axis of symmetry, the orange line, bisects that blue segment, the segment that connects the two x-intercepts. It's a perpendicular bisector of it. So, not only does it go through the midpoint, but it makes a right angle. And this is a handy piece of information here because, let's look, it's the perpendicular bisector. So this point is the midpoint. And it shares the same x coordinate as the vertex. So if we could find the two x-intercepts here for our graph, and then take the average of them, whatever x value we get is the same x value for the vertex. As a matter of fact, that's the technique that we're going to use to come up with that vertex point. So let's do this as an example. So find the x-intercepts of this graph, and then use them to find the coordinates of the vertex and the axis of symmetry. So, we've talked about some ways to find the zeros of a quadratic equation. It's called zeros because we're looking for where y is equal to 0. And that's just a quadratic equation that I'm going to solve. I could do it by factoring, by completing the square, by using the quadratic formula, or, cheating and looking in the calculator. So let's try this actually by using the quadratic formula because there's something about it that I want to show you. So x is going to be equal to negative b, so this is 8 plus or minus the square root of b squared, so negative 8 squared, 64, minus 4 times a, which is 1, times c, which is 12, all over 2 times a, so just 2. Inside the square root, we got 64 minus 4 times 1 times 2 is 48. So 64 minus 48 is 16. Oh, that's handy because that's just the square root of 16. X is equal to 8 plus or minus square root 16 over 2. 8 plus or minus 4 over 2. And I'm going to clean this up a little bit. I'll just go ahead and divide them both by 2 since they're both even. So this is 4 plus or minus 2. Okay? So let's go ahead and add them up, or add or subtract them to get the two actual values here. So I have x is equal to 4 plus 2. I've got 6. And then 4 minus 2, I have 2. So here are my two x-intercepts. So let me go ahead and put the picture of the graph up here. I've got one at 2, I've got one at 6. And I'm trying to find this point down here for the vertex. So, ignore the fact that you can actually see it on the graph. What we're going to do is we're going to average these two and find the midpoint because it's the midpoint of that segment and the axis of symmetry bisects it. Whatever x value it has is the same x value as the parabola. So let's go ahead and average these two. So the midpoint is 6 plus 2 over 2, and then it'll just be comma 0, right? So this is 8 over 2 is 4, 0. So this point right there is a 4. And on the vertex, it's also a 4. How do I get the y coordinate? Well, I'm just going to take it and I'm going to put it back into the equation to find the y coordinate. Y is equal to 4 squared minus 8 times 4 plus 12. So I've got 16 minus 32 plus 12. 16 minus 32 is negative 16 plus 12 is negative 4. So my vertex point is 4, negative 4. Now there's something else that I want to show you. Look back up here when I did this with the quadratic formula. Put a circle around it. I have a 4 plus or minus 2. Where's that 4? Does that sound familiar? That's the 4 right there at the midpoint. And the plus or minus 2, I'm going 2 this way from the axis of symmetry and 2 this way from the axis of symmetry. Pretty handy stuff. So now everything that we just did in terms of a specific example, we're going to do with some algebra with ax squared plus bx plus c. And maybe it's going to hurt just a little. Take a look. So I was just kidding about the pain. Or was I? Anyway, so since the axis of symmetry bisects the segment that contains the zeros of our function, just as we saw in the previous example, we're going to use the quadratic formula so we can find our x-intercepts to derive an equation derived from the equation, a formula that's going to give us the x and the y coordinate for the vertex, as well as the equation for the line that makes the axis of symmetry. Okay, so I'm going to take the average of the x-intercepts. How do I get both of the points of the x-intercepts? Well, I get that from the quadratic formula. So given the line, or the equation y equals ax squared plus bx plus c, I would just take the average of the two x-intercepts. So one of the x-intercepts is this negative b minus, wasn't that nice? Did you see it go all the way around? Okay. Let me do that one more time. Whoops, let me do it one more time. All right. Yeah, there we go. Way to make the video longer. Anyway, so that's the first x-intercept, negative b minus the square root of blah, blah, blah over 2ab. And then the other one, the one that's on the right-hand side, is just negative b plus the square root of blah, blah, blah over 2a. Okay, and it's average because I'm adding them together and I'm taking half of that. Okay, so let's just clean all of this up. They already have a common denominator, yes? So we can just add up the tops. So whenever I go to add up the tops, does anything cancel out? Does anything combine up? The two negative b's are going to add up. And then, hey, look at that. The two square roots, they disappear. One's positive and one's negative. All right, so I have simplified just 1/2 negative b, negative 2b over 2a, and then I could take half of, I just cancel out the 2's from the half and the 2 that's on the top. If that doesn't make sense to you, it's the same thing as this. I'll write it right up top. It'd be 1/2 times negative 2b over 2a, and then just top times top, bottom times bottom, so negative 2b over 4a. And then you would just simplify this fraction. The 2 over the 4 still makes just 1/2. Okay, so we can see that this answer is the same. So what is that? What did we just find? We found the x-coordinate of the midpoint between the two zeros, which is also the equation of the axis of symmetry right there. So what I'm going to do next is I'm going to take that value, I'm going to put it back into the equation, the quadratic equation, to find out what the y-coordinate is going to be. Oh, wait. Before I do that, though, take a look at this. So this negative b over 2a, if I go to the right a little bit, I get one x-intercept. If I go to the left a little bit, I get the other x-intercept. And notice exactly how much I'm going to the right is the second part of the quadratic formula. How much I'm going to the left is the second part of the quadratic formula. Okay, so that was worth taking a little break for. So now let's find the y-coordinate of the vertex. I'm going to do that by taking that negative b over 2a and shoving it into that formula. Okay, so everywhere there's an x, put negative b over 2a. And now let's evaluate that. So first squaring it, you square the top and you square the bottom. It's negative inside the parentheses, but once I square it, it's not going to be. And then on the second one, the b times the b on top is going to make a b squared. So this is what I've got so far. Now, I can go ahead and cancel out an a with one of the factors of a down in the bottom. Also, I need to get myself a common denominator if I'm going to add up those two fractions that have a's and b's in them. So the common denominator is going to be a 4a. On the second fraction, in order to get 4a, I need to multiply the top and the bottom by 2. So that's what this is. So 2 times the b squared on the top, and then I have my 4a on the bottom. Now I could go ahead and combine up those first two terms. If I have 1b squared minus 2b squared gives me just a negative b squared. And I'm the type of guy who likes to keep the positive number first if there is one, so I switched this around and made it c minus b squared over 4a. So there is the y-coordinate of your vertex. Let's put them both together here. Here's the xy coordinate of your vertex right there. X coordinate is negative b over 2a. The y-coordinate is c minus b squared over 4a. Now let me just mention something here. Most people don't remember how to find the y-coordinate because it's kind of complicated, but it's very easy to find the x-coordinate. As a matter of fact, you already know how to find the x-coordinate. Take a look at the quadratic formula. Do you see a negative b over 2a in it? Just take a look. Right there is the x-coordinate of the vertex. If you can remember the quadratic formula, you already have the vertex. And remember the other part of this, plus or minus b square root of b squared over 4a minus 4ac all over 2a is how far you're moving to the right and to the left of that vertex point to find your x-intercepts. Now, what I was saying before is that just memorize how to get the x-coordinate. To find the y-coordinate, you don't have to memorize that formula, this formula necessarily. You could just take that x value, whatever it is, it's going to be a number, put it back into the equation and find it. So here summarizes then, here's the equation or the formula for the vertex, the x and the y coordinate of the vertex for your parabola, and then here's the x-axis or the axis of symmetry. So notice, of course, that it's x equals negative b over 2a because it's a vertical line, and it goes to the x-intercept, or the x-coordinate, talking is really hard, the x-coordinate of the vertex. So, shall we try it on a problem? Let's. So find the coordinates of the vertex of each of these equations and the axis of symmetry too. So, I need to remember x is equal to negative b over 2a. X equals negative b, so my b is negative 24, so now it's going to be a positive 24 over 2 times my a, which is 3. So this is 24 over 6, which is 4. Here's the equation of the axis of symmetry. AOS, that's how I'll abbreviate it, is x equals 4. Now I just need to find the y-coordinate. To find the y-coordinate, why don't I just put that back into the equation? Y equals 3 times 4 squared minus 24 times 4 plus 53. I think I'm going to use the calculator on this. Alright, so I've got 3 times 4 squared minus 24 times 4, again so far, plus my 53. 5. Okay. This is all equal to 5, which means that the coordinates for my vertex are just simply 4, 5. Very nice. Now look at that problem 2 over there. Guess who gets to do that one? You do. So go ahead and pause right now and give that one a try. Check to see if this is what you got. There we go. So here, whenever you find the x-coordinate, x is equal to negative b, so negative of negative 32 is positive 32, over 2 times a, negative 2. That's going to give us negative 4 on top for a total of negative 8. So there's our axis of symmetry. X is equal to negative 8. And then to find the y-coordinate, you're just going to take that negative 8, put it into the equation, probably put it into the calculator, get negative 7. So you're finally at your vertex at negative 8. negative 7.